There we go. Everywhere I go. And I cannot run and I cannot hide. We'll start in just a minute, everybody. I just got to get things set up. It's my favorite animal, the esoteric platypus. I'm a platypus guy. All right, we should be all set to go. Hope everybody brought their questions. And yeah, welcome, welcome. Oh, my headphones aren't working. No wonder. What happens if I drop an apple? It'll fall. Hello, everybody. Welcome, welcome. What's the most enjoyable or funnest part of physics to you? When you have a model and you want it to do a certain thing, so you fiddle around with the, your parameters or whatever, and then you find that a particular set of parameters or a particular, arrangement of data or whatever it might be, when it works, when it does what you want it to do, that's the best part. Did you do Ask a Physicist yesterday? I did. The peer review thing is good, but it's also really hard to find good papers to review, and I haven't been finding a lot of good ones lately. Like I haven't found any good ones that I think are good quality for review for like the live stream. So we've just been doing this for a while, and people seem to like this, so I'm happy to do it more. Do you have a favorite dinosaur? Gallimimus. It's it's anything in the Gallimimus genus. Um, because they're basically giant fast birds. Um, do you have any controversial opinions? I mean, I don't know, maybe. Can you please explain what string theory is? So string theory is a proposed theory of everything. The idea being that, we have these fundamental particles, quarks, leptons, bosons, and so on. And the hope is that, maybe these can all be unified by a single thing. And the idea is that, well, what if you took like what if your fundamental thing was like a loop of string? Not like literally string, but like like a loop of something. Um, and the way it vibrates gives different kinds of particles. That's the idea behind string theory. And it seems to work. The only trouble is that in order for it to actually work and match our universe, there have to be these things called supersymmetric particles, and we've never detected those. And we thought that we should detect them at the Large Hadron Collider, and we didn't, so it kind of rules it out. It doesn't rule it out, but it definitely makes it less likely. Is the moon hollow and made of gypsum? No. I got Juan Maltasanta to reply to my email. That's amazing. Why do I hear you now twice? You shouldn't. That seems like a you problem. If gravity just stopped, would we suffocate first due to decompression, or would Earth explode? Earth would drift apart. The air would fly away. I don't know. That seems bad though. Does Hawking radiation violate the second law of thermodynamics? No. Is gravity fake? No, absolutely not. Do you actually believe someday in the future, far, far away, we'll solve FTL travel? I suspect not. Are there conspiracies in physics? Not really. Are religious people mentally ill believing in an imaginary entity? No, you can be rational and have religious belief. But the experience is required to do so, I just haven't had. How can I bend a spoon with the might power of my mind? You cannot. That's a movie thing. Have you read Brian Greene's The Elegant Universe? That's the first physics book I've ever read, and I loved it. Yes, I did read it a long time ago. What field of physics would be the best in the solar industry? Semiconductor physics, maybe? Have we made any like progress in the past 5 years with physics? Yes, all the time. Would a white hole not have to bend space up, which would mess with, well, not, it's not up. It just bends space in the opposite kind of way that a black hole does. So yeah, it does do that, but it's not like up, because black holes don't bend space down. The pyramids, how they build that, with lots of labor and good craftsmanship. Why do cats lick plastic why do cats lick plastic grocery bags? I don't know. So the universe vibrates, or you vibrate, or what? Well, the universe isn't the strings. We're not the strings. That would be like the fundamental particles of matter. Um, if time slows down near a black hole, does that mean that you could see the future of the universe? Yeah, you would see a lot more of the universe's future than, um, somebody who wasn't near a black hole. Do people like Eric Weinstein get in the way of actual physicists communicating like you? Yes. Yes, they do. Are you a communist? I wouldn't use that word. Do you think we'll develop technology capable of creating wormholes? I suspect not. Will we ever colonize other star systems? I hope so. It'll take a long time, but I hope so. What's the coolest thing you've heard recently? I don't know. That's not how I categorize things that I learn about. Have we made any progress? Yeah, I already answered that. Thoughts on many worlds theory? I think it should be taken seriously. What's the biggest issue with electric universe theory? Well, it can't account for the Cavendish experiment that demonstrates the existence of gravity. How can I prove gravity in my house? Build a Cavendish type experiment. Or just drop a pen. Do they just use dark matter to fill in the blanks for what they cannot explain yet? Not really. So dark matter is the name for whatever accounts for the fact that well, it's the name for a large class of explanations for the phenomenon where there appears to be more mass than we can observe, or there seems to be more mass than we can observe. So dark matter is a name for a class of explanation. There's another class of explanation called MOND, modified Newtonian dynamics, which also proposes an explanation, but MOND just seems to have, there's like tension in the MOND theories. They don't seem to work as well. From Texas Panhandler, with the $2, did we invent math or discover it? My view is that we invented it, because that's part of the day job of a mathematician, to like go just come up with math. So, but like that's not it. That's not definitively true. Like there are other serious people who hold the opposite view. When space expands, does 1 meter become 2 meters, or does 1 meter get stretched out? No, 1 meter becomes 2 meters. Why wouldn't you use the word communist or use socialist then? Yeah, I would use the word socialist. Communist has some connotations that I don't like. And I think that it's more of an idea like a utopian viewpoint rather than like a practical one. What if the acceleration of the universe just the continued inertia of Big Bang's expansion? If it was just the continued inertia, it would be slowing down, not speeding up. Is string theory a waste of time? No, absolutely not. It's a wonderful use of time. What is the speed of dark? Dark isn't a thing that moves, so will we ever live on Mars? Maybe, but let's fix Earth first. How do photons know when they're being observed? They don't. They're just detected. And when they're detected, that means that they're absorbed. If light doesn't have mass, why does gravity affect it? Gravity doesn't only affect things with mass. Gravity is the curvature of space-time. And if that's true, which it is, then it will affect anything traveling through space-time, including things that don't have mass. What do you think about simulation theory? Is there any evidence? As far as I'm aware, there's no evidence to support it, no. There's like circumstantial stuff, but can you explain the general reasons for why the majority of physicists take the Copenhagen and Everett interpretations? I don't know the sociological reasons. The Copenhagen interpretation is just what's taught. Because it's really a non-explanation. It's just, look, this is just what this is a thing that happens and we observe this, so we're just not going to ask too many questions. That's the Copenhagen interpretation, basically. The Everett interpretation, maybe it's more popular because it's very simple. It doesn't require a whole lot more than just like the basics of quantum mechanics. Do you worry about the lack of reproducibility in the published scientific papers over 70%? I'm not really too concerned with like other fields. It's not really my business. And in physics, there's not really a huge reproducibility crisis because it's a lot easier to check if something is right or wrong. If the universe is infinite, don't you agree? It might be. I lean that way, yeah. Can you expand on observed versus detected in terms of photons? There is no distinction. If a photon is observed, that means it was detected. Texas Panhandler with the $10. Thank you. What is the most obnoxious misapplication of physics that you have run into? Big fan of your work. Well, I appreciate that. Most obnoxious misapplication of physics is anytime anybody invokes quantum mechanics to justify a whole host of non-scientific beliefs. That frustrates me. So if gravity is the curvature of spacetime, is a particle accelerator just curving spacetime for our purposes? Particle accelerators aren't really changing the local gravitational field in any significant way. So no, not really. What are your thoughts on loop quantum gravity? I think it's really cute. I think cute is the wrong word. It has some implications that aren't relevant. I think it's really nice, but it has some issues with predictions, and the calculations are really, really hard. I always wanted to ask this to a physicist. What would a warp drive warping space-time look like to a far-off observer? Would it look like a dark void of space? I have no idea. Yeah, I have no idea. Although in principle, the light could just pass right through, depending on how you're doing it. Isn't an expanding infinite a contradiction? No. No, not at all. Did quantum mechanics help create GPS? Probably, insofar as like GPS relies on electronics, and a lot of modern electronics relies on transistors and semiconductor physics, which in turn comes from quantum physics. What is the holographic principle? The holographic principle is a mathematical idea that says the physics and the mathematics that describes a universe with gravity. Let me rephrase. Well, no, okay, that was fine. So the physics and mathematics that describes a universe with gravity is the same as the physics and mathematics that describes a non-gravitating universe in one lower dimension. That's the idea. What are your thoughts on the Great Attractor? It's probably just a bunch of galaxies that we can't see. Does light stay constant under extreme conditions, such as a black hole? Yes, light always travels at a constant speed in a vacuum locally, meaning that if there's a light beam passing right by you, you will always measure its speed to be the speed of light. What's your take on Eric Weinstein's geometric unity? It's not to be taken seriously. From Fear's interaction with the $10 softball question, well, I appreciate that. What do you see as the most immediate impacts of the EPA eliminating climate change regulations? That we will have reduced green energy production, we will have increased CO2 production, reduced pollution, regulation. These are all things that are serious and bad, but I appreciate the softball question. If an asteroid hit the moon hard enough to push it out of orbit, would we on Earth die? Well, only if, no, it would be bad, and very, very different. But no, we don't require the moon to live. Isn't an expanding infinite universe a contradiction? No. Did you see Luna's response video? I did. Yes. It was basically predicated on a misunderstanding of the language that I was using. So there's not much to talk about. What is conformal field theory and why does it show up in both high energy physics and condensed matter? Conformal field theory is just regular quantum field theory, except the behavior. Oh, why is my green screen being funky? Except the behavior of the quantum fields is independent of how far you zoom in. This is called self-similarity, and the fact that we see self-similarity in high energy theory and condensed matter means that it's at least important. It's an important concept, and it just happens to pop up in both condensed matter physics and in... What is happening? It pops up both in condensed matter physics and in high energy physics. So the strong nuclear force is an example of a conformal field theory, at least when the quarks are massless. So yeah, I mean, it shows up in both because it seems to be like a fundamental part of the way that we understand the world. What could be causing 3i Atlas to be moving faster than previously recorded comets? Well, it could just be that it started out faster, right? Did James Webb's telescope debunk the Big Bang? No. Anybody who says otherwise isn't familiar with the science. Could gravity be an absence more than an active force? Well, no, it's a thing that we can measure, so... Um, so by the way, we would still have tides if the moon disappeared. The tides would just be weaker. About a third of the tides that we get comes from the sun. Is all of the mass of a black hole contained in a singularity, or is a black hole made of matter denser than a neutron star? We don't know, although I kind of lean towards the latter. I suspect that there's something very dense that is at the core that we just don't understand yet. Do you think the military can alter time? No. Do you believe in time travel? No. What do you work on, and what's the most recent paper you published? Well, I'm not going to tell you the most recent paper I published because that would give away my personal identity. Um, but I work on relativity, I dabble in some quantum gravity stuff, and I do differential geometry as a pure mathematician as well. Can you explain why the slit experiment shows light behaving differently based on observation or not? So observation means detection when we're talking about light. And when you detect a photon, you're either detecting it there or you're not detecting it there. And that fact means that it has to behave as if it's either there or it's not there, rather than behaving as if it's in both places. Do you agree that we will find life on another planet or moon within the next 59 years? I don't know. I have no idea. I need to know this. Why do particles behave differently when being observed? They behave differently when being interacted with or being detected because that requires doing something to the particle. If matter bends spacetime, what is it that's being bent? Spacetime. Thoughts on Star Talk with Neil deGrasse Tyson? Smart or just yapping? I don't watch it, so I don't know, but Neil deGrasse Tyson is a very good science communicator. How hard is it to find a job as a physicist? Generally, generally the job market's hard. How long did it take you to get your degree? Well, I have 4. And so between the 4 of them, it took me 11 years. Da, 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 da. Is it possible that gravity itself has its own weight? Yes. Yes, it does. Gravity gravitates. But it's very, very small. The effect is very, very small. Do you honestly believe that we went to the moon but cannot go back because the technology was destroyed? We can go back. It's just expensive and we'd have to rebuild out the industry. From Rodrigo Monte with €5. Thank you. Why is it more common for stars to come in pairs and why our sun is just one? Well, so stars form from nebula, nebula, which are basically just gas clouds. And if the nebulas are big enough, which they often are, then they'll collapse into more than one star. And so if that happens, then you end up with a binary system if they're close enough, or if something kicks one of them out, then, or you could end up with a trinary system where one of them gets kicked out and the other two stay in a binary orbit. So there's a lot of interesting dynamics, but it's essentially just because gas clouds are big in space and they tend to collapse. Now, our sun is just one. I mean, it's bound to happen occasionally, and it could be the case that life forms more easily on planets or around stars with one sun because the orbits are more stable, perhaps. Can you make a video on the PhD applications? I want to apply for PhD in QFT. I think I did a very long time ago, but maybe I'll do another one. It's a good idea. What are your degrees? I thought you had 3. No, I have a bachelor's in mathematics, a bachelor's in physics, a master's in physics, and a PhD in physics. Have you looked into Harvard space research lately? It wasn't Harvard, it was Avi Loeb, and yes, it's basically, if you're talking about the alien thing, like, he's overselling it to the media like he always does. How is information not lost in Hawking radiation? Hawking radiation is the information that's not lost. Right? That's the whole business. You are not saying anything you originally discovered, you're parroting everything you've been taught. Well, that's not necessarily true. But I mean, look, if that's the view that you have to have so that you can ignore the scientific consensus on things, more power to you. Do you think we're in a simulation? I don't. How can I see the wave nature of neutrons? Well, you can do neutron interferometry, but that's hard to do without a lab. So, you know, it's hard to see otherwise. How is information not lost in Hawking radiation? Hawking radiation is the information coming out of the black hole. That's the whole business. How did the universe form from an explosion? It wasn't an explosion. The universe was in a very orderly state in the early universe, and then it expanded, becoming less orderly. Um, Silly, who's faster in a merry-go-round? Are the people closer to the center or the ends of the ride? I don't know what that question means. How hard is it to earn a PhD? Well, it takes a while. Um, Black holes in models seem to have infinite gravity in most models. Is this accurate or is it just an area we don't have any data for? We don't have any data for it. And actually, most models, if you just count by quantity, most models don't have a singularity in the black hole. Rather, it's just the most standard model has a singularity in the center. That would be general relativity. Um, could quantum computers help us discover new laws of physics? Maybe. About quantum mechanics, perhaps, but quantum computers are not magic, right? What do you think of the idea that our universe exists in a black hole in another universe? There's no evidence for that hypothesis. Is gravity empirically proven? Definitely, yeah. Um, what is your favorite theoretical concept? I like the concept that physics is basically geometry. Why isn't there an inward pressure since the universe is expanding, thereby creating a vacuum? The universe isn't creating a vacuum. Blitz is reading. Yeah, so I do have more than one platform, so I'm trying to read questions from both. How is gravity empirically proven? With experiments like, or with Cavendish type experiments that have been done for the last 250 years. How do you create light, accelerate electrons? Well, so you answered your question. Yeah, so one way to create light is to move electrons around. Okay, this guy's just spamming. Are you a physicist or an astrophysicist? I'm a physicist, not an astrophysicist. Um, can quantum entanglement really transfer information faster than light? No, it cannot. There's something called the no communication theorem, which mathematically demonstrates that you cannot transmit information with quantum entanglement. And it's kind of not surprising that you can't. The way that the thing that happens faster than light, if anything happens faster than light in entanglement, is the collapse. But until you measure it, you don't know if it's collapsed or not. And until you compare with somebody else, you don't know if it's collapsed because you measured it or if it was already collapsed because they measured it. And so you have to go back and compare it even after you make a measurement. So you can't know if they transmitted anything or if, this was just a result of some random chance from it collapsing as a result of you. Can you explain that physics is geometry thing? Yeah, so general relativity is the geometry of space-time, and the standard model is the geometry of principal gauge bundles. So like it's geometry the whole way down, at least the fundamental level. Collapses communication. It's not. You can't detect when the wave function has been collapsed by somebody else. What kind of matter could be in the center of a neutron star? Well, probably neutrons. Seems to be. Do you know the failures of the Cavendish experiment? Well, not really. They've been very, very careful with eliminating systematic errors. But I'm sure random commenter on TikTok will come along and debunk 250 years of experimentation. Do you have any non-academic pursuits? What are your favorite pastimes? I play video games with friends. Hi, I'm a physics undergrad. Do you know where I can do research since NSF REUs have no money? You are currently in a bad position. That's the nature of things. I mean, there are still going to be some REUs, probably, but maybe email a professor at your university. If time is relative, does that mean the past future still exists somewhere? Well, they don't exist somewhere, they exist somewhen. Um, what is the Langlands program? It is a very complicated algebraic geometry thing that I don't understand. Can you explain why there are two event horizons in Kerr black holes? Why? I mean, it's just what happens if you continue the coordinate system. If you analytically continue past the event horizon, that's just what happens. It's because the denominator in the time-like piece in standard Kerr coordinates, or I guess Schwarzschild-like coordinates, the denominator has two zeros because it's not linear, or rather, it's not first order in R, it's second order in R. Is Eric Weinstein onto something? No, he is not onto anything. Have we only measured the one-way speed of light? Nope, that's not even in principle possible, at least as far as I know. You just learned so much to believe what you have learned, but you learned not so much to understand. Okay, I'm sure that that's your view. Look, if that's your view, you can hold it. It's just not going to get you very far. What are your thoughts on strange matter? I'm skeptical that it exists, but it's really, really hard to study um, baryons and hadrons and mesons. Like they're very, very hard to study because the strong nuclear force is very, very complicated and the mathematics is very, very challenging. So, they could exist. As far as I know, we don't really have evidence that they exist, so make of that what you will. $5 from the Cosmic Wanderer. I have a question. Can you explain quantum travel and could there be antimatter stars? So I don't know what quantum travel is. That's not really a thing in physics, but antimatter stars could definitely exist. However, we've never seen them. And if they did exist, we would see them because they'd be basically annihilating with their matter surroundings all the time. And that would be very, very bright. If only we could raise funds for physicists. I agree. If only. So is it justified being a physicist and also a believer? Look, I think that you can be a physicist and be a believer if you have had certain experiences that are very, very compelling. Now, whether it's justified or whether those experiences have alternative explanations that perhaps are more justified in believing, maybe that's the case. But I mean, yeah, like, look, I'm not going to say that that it's never rational to have a belief in God. Like, it just depends on how you weigh the evidence and the experiences that you've had. And I just happen to not have had those experiences. Does superposition not prove sentience or a higher power? No, it does not. The two things don't seem like they're related at all. What happens when antimatter interacts with matter? Most of the time, you get annihilation. And when you get annihilation, you get photons almost exclusively. These are gamma rays. So if you have a positron and an electron, if their wave functions overlap, then they will release gamma rays with an energy of 512 kilo electron volts. They will release two of them in opposite directions. Why do you think CCC is wrong? Space resetting feels really elegant, and most everything I see is a cycle. So as far as I know, there's not really a good solution of how to deal with massless things that don't decay. And that's my understanding is that's trouble for CCC. Also, there's no mechanism for how you can get the conformal geometry reset, like the conformal rescaling. I don't understand the mechanism there. What's your opinion about Bob Lazar? He's a hack and a fraud. Your volume is a tiny bit low. Move mic about an inch or two closer. Okie dokie. How's that? Better? You think all things what people view as ghosts be evidence of life in other dimensions? No, I don't think so. I don't think that we really have good evidence of ghosts. Any compelling fine-tuning arguments you've heard? Not really. If you had unlimited funding, what physics experiments would you run first? Unlimited funding and unlimited resources and production capability, I would just build a particle accelerator the size of the solar system. And then we would know string theory is true. And we could probe quantum gravity directly. $5 from Cosmic Wanderer. Thank you again. I appreciate you. W in chats. What I mean is, could quantum travel happen, or are there other FTL methods you like? Quantum travel is not a thing at all. It's not a thing. I don't even know what that means. Now the only proposed mechanism that actually relies on real physics for FTL would be like a warp drive, where you essentially you could either create a wormhole or you could use like an Alcubierre drive or something like this. But those don't seem possible at all either because they require negative mass. How does the sun burn if there's no air? The sun isn't on fire. So it's a good question. It's a really natural question to ask, but the sun is not on fire. The sun is just a glowing hot ball of plasma. And the reason it's glowing hot, thank you for the money gun, Robert. The reason it's glowing hot is because in the core of the sun, protons are fusing with each other. They're undergoing nuclear fusion. And that happens to release a lot of energy. So that energy gets kicked out and then it gets distributed amongst the sun and it gets really hot and then it glows. It glows just like how if you heat up a bar of metal, the bar of metal will glow and it doesn't need any air to do that. Do you think we're going to find a solution to the measurement problem in quantum mechanics? Maybe. Maybe. It really depends on what... There are ways that it could be solved, in principle. Like if you have a dynamic collapse interpretation of quantum mechanics that's proven true, then that would solve the problem, right? But maybe those interpretations are not true. Do you feel you forget a lot of stuff you needed to grad? Like, could you pass your senior finals today? Probably, yeah, I probably could. What does CP violation really represent? So CP is charge parity. Um, so there's three kind of main discrete symmetries in the standard model. You have charge symmetry, so if you swap all the positive charges for negative charges. You have parity symmetry, means you swap all the left-handed for the right-handed stuff. And time symmetry, meaning that you take all of the things that are traveling forward in time and you run them backwards in time and vice versa. So CP symmetry is the idea that if you swap the charge and swap the handedness, then everything should be the same. Like all the physics, all the observables should be the same. But interestingly enough, the weak nuclear force violates this. It is the case that, and I made a video on this a while ago, this was actually proved by one of the most talented experimentalists of all time. Her name was, well, she was Chinese, so I can't pronounce her first name, but she was often referred to as Madame Wu. She was a brilliant experimentalist, a brilliant physicist, and she proved, using cobalt, that there's a preferred handedness and a preferred charge for certain nuclear decay processes. And I made a video on it a while ago if you want more details. Dynamic collapse as DOC Penrose model? Yeah, that's one example. Why do we need to explain gravity at the quantum scale if we already have proven gravity is not a force but the curvature of spacetime? All forces are curvatures. Gravity is the curvature of spacetime. The quantum forces are curvatures of principal gauge bundles. Just because it's a curvature doesn't mean it doesn't need a quantum explanation. Because, look, let's say that you have an electron. An electron has mass. It should cause curvature of spacetime. But if it's in a superposition of locations, where does it cause the curvature? Did Plato or Aristotle have a degree or high school diploma? Probably not. I don't think that they had invented those yet. So it seems it's a weird question to ask. What was the hardest math class you've taken? The hardest math class, probably not that hard now, but I took a point set topology course as a freshman in undergrad, and that was a mistake because I wasn't ready for it. But the hardest class that I took, and I did end up finishing it, was topological quantum field theory. It was more of a physicsy math class. That was really hard, and I still don't understand everything that was happening there. Do you think parallel worlds or alternate timelines exist? If so, why or why not? Kind of, sort of, in the sense that I take the many worlds interpretation of quantum mechanics seriously, but these are not parallel worlds, or they're not like in another place. They're just here. It's just a superposition of a whole bunch of different ways that the quantum systems could have evolved. What's the best way to learn differential geometry for physics? Best book. There is a book called Geometry for Physicists by Frankel, if I remember correctly. Let me pull it up. Yeah, it's called The Geometry of Physics by Theodor Frankel. I like it a lot. I think it does a really good job. So it's a good intro book. It's definitely not like a good book to like master differential geometry, but it's a very good book to start. Also, you can pick up Sean Carroll's Spacetime and Geometry. That's where I started with differential geometry, which is a general relativity book. How much of physics theories can I possibly understand without actually learning the math? Newton's laws, probably. Maybe some classical mechanics. That's about it. You can have like a surface level understanding, but not a deep understanding. What do you think about Neil deGrasse Tyson? I think he does a good job exciting people about physics, about science. I think he's a good science communicator. I don't know how he is as a person. I've never met him. I'm not going to comment on his views about that kind of stuff. But I think generally speaking, he's been an influence for good on getting people interested in physics and science. Is the age of the universe 12.8 or 13.8 billion years old? The age of the observable universe is 13.8-ish. If the universe is cyclical, is everything in it also a loop? Like, have I lived 100 times? Depends on the cyclical model, but yes, in many of them, it would, well, at least in some of them, it would be a genuine cycle, genuine repeat of the same thing. Which physicist do you think has the most impact on the current field? Einstein. It's got to be Einstein. Of course it's Einstein. Maybe Feynman. Feynman also had a huge impact on like research today. Maybe Kenneth Wilson as well. He's a big deal in condensed matter and a lot of like QFT as well. Field theory. What does the word relative mean in physics? Relative just means that it depends on a frame of reference, typically. Thoughts on the alien spaceship coming in November to attack us? It's almost certainly false. It's not going to happen. I made a video about it already. Avi Loeb likes to basically make or be hyperbolic to the media, and I don't think that's really a good thing. Do you really believe the universe is flat? It's flat in a three-dimensional sense. At least that's what the data says. What's a bundle/principal bundle? That's a deep topic. A bundle is basically a way of kind of attaching data at a point in space-time. And it's attaching like different possible values of data. That's the simplest way I can phrase it. Do you know anything about Antimatter? I know that he was involved in proposing like the first non-flat model, I think. But that's all I know. How would a particle accelerator the size of the solar system prove string theory? Well, it'd either prove it or disprove it, but if I remember correctly, somebody's done the math and shown that if you built a particle collider that big with current tech, then you would be able to to energize particles to sufficiently high energy that you could probe the scale where if string theory is true, you should be able to detect it. And so you could either verify it or falsify it. Why are we studying CFT in 2 dimensions instead of 4D? Well, so first of all, string theory is a 2D CFT. So that's one reason. Second, CFTs in 2 dimensions are very, very different from CFTs in any other number of dimensions because the algebra, the conformal algebra for a CFT in 2 dimensions is infinite dimensional, whereas in other dimensions it's finite dimensional. So it is different, and it's different in an interesting way. So people study it, and it's generally motivated by stringy stuff. Universe isn't flat. It's like it's expanding like dough in an oven. When I say flat, I mean that it has vanishing spatial curvature. That's what flat means at a technical level. And that's compatible with it expanding. What's your favorite standard model particle? I like electrons a lot. They're pretty good. Do you prescribe to the dark matter energy hypothesis? Yeah, well, neither of them are specific hypotheses. They're kind of just like names for a set of explanations. The Bible study spot with $2. Anything about the Bible that you do like? I mean, there's some cool stories in it. I like learning about like the mythological history of people groups. I think that's interesting. How significant is the geometry of toroids in physics? Not really at all. Do you believe rockets work? Yeah, of course they do. That's a weird question. You would have had well over 100K likes if people had double tap. That's true. Everybody, you guys should like the live, whether you're watching on TikTok or on YouTube. Like the live. We can get more people and therefore more questions in here. What's the difference between a Riemannian manifold and a pseudo-Riemannian manifold, and why is the latter required for GR? Great question, Tim, with the $5. Thank you. So a Riemannian manifold basically doesn't have time, and a pseudo-Riemannian manifold does have time. So in a Riemannian manifold, there's no way of distinguishing the different dimensions. They all are kind of the same. They're basically the same. They have the same characteristics. Whereas in a pseudo-Riemannian manifold, there's some dimensions that behave in one way and other dimensions, possibly more than one, that behave in a qualitatively distinct way. And so because time and space are not the same thing, they're just intertwined, you need a pseudo-Riemannian manifold. What a pseudo-Riemannian manifold is that it has a metric, as a pseudo-metric, that says that the distance between distinct events can be 0. And the distance between distinct events can be negative or it can be positive, depending on whether it's space-like, time-like, or null separated. Is quantum immortality practical? No, it's not a real thing. So not the universe in a black hole event horizon hypothesis. That's not even a hypothesis. There's not even like a theory there. There's not even like a testable thing there. At least not yet. What's your theory on how life started on Earth? I guess chemistry, but I'm not a chemist. So you like the Bible as literature? I mean, some of it. Some of it's like wildly boring, like the list of names parts and like the list of laws parts. But some of the stories are quite interesting, especially if you summarize them and make them, written in a more modern way. Absolutely. Like the story of the Exodus, it's fascinating. It's like a great story, right? Do you think the opposite of time dilation is possible, i.e. accelerating the perception of time? No. No, you can't do that. That's not really a thing. There's a slowest or there's a fastest that time can go. Um, and that happens basically in empty space far away from anything. Um, not and then basically not moving relative to something else. Hmm. Do you think the... Oh, I already answered that. If we started from a Big Bang, what was the catalyst that started everything in motion before the time? Nobody knows at this point. Is the real projective plane used in any practical physics work? Probably, not that I'm aware of, but there are attempts to do projective compactification, which would involve the real projective plane, or rather, like RP3 or RP4 or something like this, to study flat spacetimes and then do holography there. People are taking that seriously. Bacon and Bush with the $5. And think of an atheist response to God bless you. Data guide you, reason find you. Either way, thanks for what you're doing. I appreciate that. Those are good ones, though. I'll have to think about them. I'll have to try to come up with a good response. Why has gravity not been proven? It has been. Definitely has been. Anybody who says otherwise isn't familiar with the experimental data. I mean, it's been proven in as much as like electricity has been proven, right? What are neutrinos? Neutrinos are the chargeless cousins of electrons. So electrons are tiny little particles. They have a little bit of mass. They don't like to overlap with each other. And they have charge, which means that they can interact with light. On the other hand, neutrinos have all of those properties, except they can't interact with light because they don't have charge, so we can't see them, which makes them really hard to detect. How long until we can all have a quantum computer in our homes? I don't know if we ever will, because quantum computers are not like... There are some problems that quantum computers are famously better at solving than, or are like known to be better at solving than classical computers, but not every problem is that way. Classical computers are often just as fast as quantum computers, and this isn't like a technological issue, this is like a fundamental issue. We got $5 from Grimlock, as always, asking me to hydrate. Thank you so much. What does it mean to say that a photon has energy but zero mass? Well, it means that there is it means that that photon can, in some sense, transmit energy from place to place. So you can have like an electron that has some energy, then it loses some energy, gives off a photon. That photon can then go and kind of transmit that energy from the first electron, and it can go hit another electron and give that other electron additional energy. But it doesn't have to have mass. Energy and mass just aren't the same thing. What do you know about the Earth's ring current and the M magnetic field it generates, if anything, by chance? I'm not familiar with the phrase ring current. Are you talking about the convective currents in the liquid outer core? Because those are convective currents, but it's, as far as I'm aware, it's not like just a single ring. Yeah, so those generate magnetic currents. It's called the geodynamo effect. There's a lot to read about there. So neutrinos are the measurement of the collapse of the neutral charge state. No, neutrinos are a fundamental particle. I don't know what the collapse of the neutral charge state is. Are you talking about Compton scattering? Yeah, sort of. What do you think happened to the guy that created gas out of plastic? Do they kidnap? I don't think anybody kidnapped him. Like, he didn't invent that. That had already been patented. It's just really energy inefficient, so nobody did it. It's not worth the money. He just hyped himself up a lot. How do we know the observable universe is roughly 90 billion light years across if we can only see 13.8 billion in each direction? No, we can see 46.5 billion light years or so in each direction. And when we say we can see 46.5 billion light years in each direction, what that means is that the things that we're looking at now are that far away. Because the light that they emitted, the light that we're seeing now was emitted when they were much closer, but the universe has expanded since. Yeah, pyrolysis has been around for 140 years. Exactly, yeah. How can a physicist speak about God? Can a theologian speak about physics? Well, if they are familiar with the ideas, sure, yeah. I mean, Georges Lemaitre was a famous physicist, was also a theologian, and he was a priest rather. So he was a physicist that could speak about God, and he was a priest that could speak about physics. You're allowed to talk about whatever you want as long as you know what you're talking about, right? Um, three torus shaped universe are flat. A three torus is flat, turns out. Like it is spatially flat. Um, if you could choose one book or medium to let adults which are unfamiliar with the basic of physics self-educate, which would you choose? If it's allowed to be a textbook, I would just recommend a textbook. Otherwise, basic ideas of physics. Probably the theoretical minimum, I think, by Suskind. I've heard good things about that book. I haven't read it, but I've heard good things about it. Wasn't Heisenberg very religious? Potentially, I don't know. I'm not familiar with what his religion was. Does light exist outside of time? No, light travels through space-time. What's your intake on the theory that our universe is inside a black hole? It's not a theory. There's no predictions that it makes. There's no data that it can be tested against. It's not a theory, at least not yet. What got you into physics? It was black holes. Black holes are cool, and I think that they're neat and worth talking about and worth thinking about. Einstein was very religious. Einstein was very non-religious. Einstein wasn't religious at all. Famously, he wrote that he thought religion was like naive and like for children. What do you think of Vedic science? I'm not familiar with it. On a percentage scale, how likely do you believe we are living in a simulation? Like less than 1%. I don't think we have any data that supports that. Can you explain Bragg's law? This is a light thing, right? If I remember correctly. God, it's been a while. Yeah. Okay, so this is. Oh no, Bragg's law is about X-ray scattering. No, I don't know a lot about Bragg's law. I was thinking of Brewster's angle. Both start with BR. Yeah, so I'm not familiar with Bragg's law, so I can do some. Maybe I'll make a video about it. You know what? That'll make me learn about it. I'll put it on my list of things to do. Thanks for the suggestion, though. Yeah. So by the way, that's a good way to learn about physics is to teach it, right? Learn about stuff that you don't know. How difficult is second year quantum mechanics course in a physics degree as I'm doing it next year? It will be, almost certainly it will be your weeding class. At least at my university it was. My second year undergrad quantum mechanics course we started with like 85 or 90 people and we finished the semester with like 30 people or 25 people or something like this. So it's hard. And it's not even mathematically hard. It's conceptually very challenging. How good do you have to be at math to become a physicist? You have to be fluent. That's the way to think about it. Do you think we could use dark matter or an intense gravity to create energy like a Dyson sphere? How would gravity or dark matter create energy? Like no, I don't think so. Like what the reason a Dyson sphere works is because like you're collecting the light from the sun. Do you offer tutoring in physics? Not at the moment, no. What about how gold was made two supernovas hitting each other? That's not a question. You answered the question. Do you have a bachelor's or PhD? I have a PhD. Who wrote your dissertation? I did. What? Oh, no. I was writing down a list of things to make a video about. Right. Yeah. I mean, like, I'm not a X-ray interferometer. I don't do, I'm not an AMO experimental physicist, so, like, I don't do X-ray crystallography, right? It's just not in my forte, if you will. Why can't I stick my hand through a wall? Well, because there's like electrons that produce electric fields. Those electric fields make the electrons in your hand be pushed away. Why don't we study human nature more to explain things in society? We do. That's what, like, sociologists do, right? What creates wind? Like, does it never stop and keeps blowing forever? Where does wind come from? So I'm not an expert on it. I'm not like a meteorologist, but my understanding is that wind basically results from uneven heating as a result of A, cloud cover, and B, the rotation of the Earth. So the Earth spins, so you have different parts getting warmer at different places, and the clouds that we have will make some places warmer than others because of the shadows and so on. And when you have different pockets of air getting heated by different amounts, you're going to have flow. That's what wind is. That's at least my understanding. Um, da, 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 da. Do you think that's what happened, and do you think it's... I don't understand what the question is. What if the universe had 180-degree rotational symmetry instead of 360 degrees? That would be weird. That'd be very weird. um, is your wife also into physics? No, not at all. Why does mass curve spacetime? It seems to be a law of physics. This just seems to be a thing that mass does. At a certain point, there's not an answer to why. Like, why do like charges attract? Or why do like charges repel, rather? Just seems to be what like charges do. Does the second law of thermodynamics suggest entropy will eventually spell the death of the universe? Not necessarily, no. Like, for example, if the entropy of the universe is already infinite, then it will just stay infinite, right? Do you believe in many worlds theory of quantum mechanics? I take it seriously. I think it's worth taking seriously, yeah. Can you give a high-level explanation of string theory? If you mean a high level, you mean like not complicated. The idea is the idea is pretty simple. We in quantum field theory, we typically think of particles as being like fundamental zero size objects. They're like they're not spatially spread out, or rather they don't have to be spatially spread out. They're point particles. But string theory says, okay, but what if not? What if actually they have a size, and it's because the particles are actually made of tiny vibrating loops of string, basically. Now, this has a lot of advantages. One of the advantages is that because in quantum field theory the particles can have arbitrarily small size, you can basically get infinities appearing in your math. But if string theory is correct, then the loops of string, or the little pieces of vibrating string, it's not literally string, by the way, the little vibrating things, they have a finite size. And so the scattering, the probabilities of scattering, the probabilities of measuring various things, always stays finite because you never get to like a zero size, and so the probabilities never blow up. So there's a huge advantage there. It solves kind of like this issue with renormalization and all of this. Also, it happens to be the case that one of the ways the strings can vibrate is one of the ways the strings can vibrate is precisely in a way that matches the way that we expect gravitons to behave, which would be the proposed particle that describes gravity. So it has a lot of advantages. The disadvantage is that it requires 10 dimensions, 9 of space, 1 of time. It also requires supersymmetry. At least the best version of string theory requires supersymmetry. And we don't observe supersymmetry in our universe when we do experiments. So unfortunately, it's probably not there. I missed a bunch. What is the God particle? Stop dead naming the Higgs boson. The God particle is a pop science name for the Higgs boson, named after Peter Higgs, who's one of the people who contributed to this, or theorizing about it first. It is a fundamental particle, and it is as a fundamental particle, it's an excitation of a fundamental field, and that fundamental field is the thing that's responsible for giving other fundamental particles their mass, except neutrinos, because neutrinos are weird. Do you think that dark energy could just be infinite or stronger levels of vacuum? Well, the vacuum is like a unique thing, so it doesn't really make sense to talk about like stronger levels of vacuum. Some people think that dark energy, or at least for a long time, it was thought that dark energy was the result of vacuum energy, the energy associated with the quantum vacuum. We now have better reason to think that that's probably not the case. Does faster than light travel mean going back in time? Faster than light travel isn't really well defined. I mean, like, if you can go between point A and point B instantaneously, say, then some other observer, say at point A, would have noticed you in their own past. So in some sense, yes, it can mean that. Um, did you go to Harvard? No, I didn't. Just because you have a PhD doesn't mean you're distinguished in every topic. Never said I was. Is there a YouTube channel that teaches physics from the beginning? Probably. Probably. I don't know what it is though. They made a Higgs boson once. They made it a lot more than once. What's faster, a speed of light or a speed of dark? Dark doesn't have a speed. Dark isn't a thing that moves. Is information more fundamental than matter? Some think so. I'm on the fence. I'm not super convinced one way or the other. I've always wondered if light can be concentrated, and if so, to what extent could it be concentrated to a point where the amount of photons in any given space could bend or redirect other photons? This idea is, if you take it to its logical extreme, the question is, can you make a black hole purely out of light? The answer is that, like, hypothetically, yeah, it's called a Blitz, but we have good reason to think that you could never make such a thing in our universe because the energy densities required just don't exist. But yeah, hypothetically. Could dark matter be matter and energy in a state of preserved quantum coherence? Energy is not a thing. So I don't the question seems like it's making a category error. What is happening at the center of a supercluster? Lots of galaxies orbiting quickly. Um, is it true that bosonic fields exist, and how exactly do they work? Yeah, of course bosonic fields exist. The electromagnetic field is a bosonic field. I don't know what you mean by how they work. Classically they obey certain equations, like Maxwell's equations for photons, for example, or the non-abelian Maxwell equations for gluons, I guess, which are horribly nonlinear. And then at the quantum level, they behave in a very complicated way, describable way, say, for example, quantum electrodynamics. Do photons interact with each other? They can, but it requires very high energy and it's very rare. There's something called the Schwinger effect, which basically is a type of photon-photon interaction. There's also something called, is it called four-photon physics? There's a name for this thing though. It's basically a box diagram. I know that there's a diagram that I guess I could just draw the Feynman diagram, but I'm not going to do that right now. So yes, they can. It's just rare, and it's a higher order effect, meaning that it's less likely to happen. There's also nonlinear effects, by the way, where you can say combine two photons into one. That happens in nonlinear optics. I want to get a physics degree, but for the fun of it. Do it. Do it. A while ago, I heard about supercooling laser that brings things to very low temperature. Still a thing. Yes, this is called laser cooling. And it's really, really neat how it works. So essentially what happens is that you have a whole bunch of gas molecules that are moving in random directions because they have some finite non-zero temperature. Now, what happens is that those gas molecules, those gas atoms rather, or those atoms in your gas, maybe your rubidium atoms, whatever it is, they will only absorb light of a certain frequency because of the way their electrons are configured. They can only interact with light of a certain frequency. And so, but because the atoms are moving at different speeds in different directions, some of those atoms will be moving towards a laser light source and some will be moving away. And the ones that are moving towards the laser light source will see the light source blue shifted ever so slightly, basically the Doppler effect. It's moving towards the source so the light gets slightly bluer, slightly higher frequency. And so what you can do is you can fine tune the laser so that it's only absorbed by the atoms that are moving towards it and not absorbed by the atoms moving away from it. And when the laser is absorbed by those atoms moving towards it, they get pushed in the other direction. And so this uniformizes the motion. And because the motion is more uniform, the average velocity gets lower and you end up with a lower temperature. It's really, really neat. Whoever came up with it, I'm sure I can find their name. Brilliant idea. It's super cool. No pun intended. Can you tell if Schrodinger's time-independent wave equation is a wave equation or a heat equation? If it's the time-independent one, is just the Laplacian equation. It's just a Poisson type equation. The time-dependent one, the one with the time derivative, it's kind of a wave equation, kind of a heat equation. It's not really either because it's complex. So it turns out wave functions, wave solutions do satisfy it. So in that sense, it's a wave equation, but it's also diffusive. So is Hawking radiation wrong because it implies information is destroyed? No. So at like a macroscopic scale, it looks like it's completely like it's thermalized, but the typical view is that it actually does capture the information, just in a highly scrambled way. If fundamental constants vary, does that imply broken energy conservation via Noether's theorem? It very well could, yeah. But you can have broken energy conservation for other reasons than just your fundamental constants varying. Why do you keep asking if mini dwarves could be living in our scalps? It's a weird question. Can you re-explain how scientists recently froze light? Yeah, it wasn't light that they froze. I did make a video about this a while ago, but essentially what they did is they took light, they shot it at a piece of like some sort of material, and then that material re-emitted the light sometime later. And so the thing is, oh, they froze the light in the material, but no, what happened is that the material absorbed the light. It became something else. It became what was it? A polariton, I think is the correct phrase. And then that polariton eventually became a photon again, or became light again. Oh, my stomach's rumbling. Has quantum entanglement actually been proven or observed? Yeah. Yeah, definitely. I mean, you can't observe it directly, but you can definitely observe its consequences. So that's how we do science typically. Yeah, they produced a supersolid, but the supersolid wasn't of photons, right? Are there any star systems that exist but are currently not observable, detectable by JWST? Yeah, I mean, there are probably lots of stars we can't see. Can you explain dark matter? Yeah, so dark matter, it's not that complicated, but basically, so one of the facts about gravity is that if you have a big heavy thing in the middle, things orbiting it will move at a certain speed. And if the thing is heavier, the things orbiting it will move faster. Now, when you go look at galaxies are basically big heavy things, and the stars at the edges of them orbit the center, or orbit all of the stuff in the middle. And you can look at the speed of the stars orbiting the galaxies and compare it to the amount of light that you see from the galaxy, which should give you some information about how much mass there is, because the mass of a galaxy is like glowing dust and stars, basically. And so you can see those, and so you should be able to estimate at least how much mass there is in a galaxy. And then you can compare that with the speed at which the stars are orbiting it. The trouble is that when you make that comparison, you find out that there's not nearly enough mass that you can see for the stars to be orbiting as fast as they are. And so people postulated the idea that there's mass that we can't see. Dark matter. And dark matter also makes other predictions. For example, if dark matter exists, then we would expect that there's more gravitational distortion in the form of gravitational lensing than is caused by the light that we can see. And we do see that. So there are other ways to test the dark matter hypothesis, and almost all of these tests have come true. Now, it doesn't mean that dark matter is like something that we can't see. It could be that we're misunderstanding gravity. But at least there's fairly convincing evidence to me. Are different dimensions physical spaces? There's no evidence of different dimensions. What helped you get through school to get to where you are now? Well, I mean, like, probably my wife. But like, I've always loved school, so like, it was never really a struggle for me. Should I still major in physics if I did bad in high school math? You can, but in order to be successful in physics, you have to be fluent mathematically. Fluent in mathematics. How, according to general relativity, is Earth accelerated upward rather than the ball accelerating downward? That's not really true. I mean, there's a frame of reference where you can describe it that way, but that's not, like, it's not really true. What's happening is that time and space are both bending in such a way that the most efficient way to travel through time is to also move towards the big heavy thing. What do you think about UFOs? I think that aliens probably exist. I doubt any of them have ever visited us. What if locality is emergent, not fundamental? How does that impact Bell's theorem interpretations? Um, so Bell's theorem just requires no communication between the observers. So whether or not locality is emergent or not, you could just still not communicate. But I mean, one of the ideas behind one of the resolutions of the observations involving Bell's theorem is that locality is emergent. That like there is just one quantum system and space-time is just an emergent thing. It's one of the implications, perhaps, that you can draw. Among the most expensive experiments which are possible in experimental physics, which one offers the highest scientific benefit relative to its cost? That's so subjective. I have no idea how you could drive that. But I would say that, in my view, building LISA would be amazing. LISA is the laser interferometry space antenna. It's set to be launched in the 30s. Set to be launched in the 30s, if I remember correctly. I don't think it's that expensive to build. And yeah, so it's the mission cost is 500 million euros, which compared to the LHC, which was like several billion euros, I think that LISA will be very, very important, and it's at a pretty low cost. I don't know what an alien looks like to know if they have visited, so how would I know? Well, that's a fair point, but if aliens exist, they almost certainly don't look like us. And so I feel like we'd be able to tell, we'd be able to notice that something out of this world is here. Do you think that there have been advancements in research in gravity manipulation that isn't available? No, I don't think so. Yeah, the 30s sound like, yeah, the 2030s. Best academic STEM field 10 years from now for kids. Something given AI. Nobody can predict what's going to happen in 10 years. Nektu with the $5 for the love of science. Thank you so much, Nektu, as always. The Sheob operator, yeah. That was a Weinstein reference, by the way. Could non-carbon life forms exist like aliens? People have speculated that silicon-based life forms can exist, but I remember reading, and I could be misremembering, but I remember reading that like actually there's pretty good reason for why we suspect silicon life forms probably don't exist. From Juan with the $5, if the universe were to end in a big crunch, would it be observable from our perspective? Well, we'd be dead. So no. No, we would die, right? We would be crunched. So LISA to transport power or radio microwaves? No, LISA is a gravitational wave observatory. How do you feel about Planet 9 exists? I'm leaning towards no. What's the difference between philosophy and theoretical physics? Theoretical physics is still connected with reality. How far is light from physics from achieving sci-fi like interstellar travel? Very far. Like wildly far. I heard the crab look is the most common type of conversion of evolution, so aliens are most likely to be crabs. If so, true. So would it be instant? No, it would just, I mean, we would see the universe collapsing rather than expanding, but we wouldn't see the actual big crunch. When a particle's Compton wavelength equals its Schwarzschild radius, is it a particle or a black hole? It's probably, well, okay, so the thing is every particle has a momentum that corresponds to a Compton wavelength that's smaller than a Schwarzschild radius from some observer's perspective. So it turns out that kinetic energy is not sufficient. Kinetic energy of a single moving body is not sufficient to create a black hole. What was the cause of the beginning of time? I don't know if it had a beginning of time. Are they discovering anomalies in the far universe that question creation's timeline? Not really. From Johnny the Goat, a Cash App donation. Thank you, Johnny. No, go away. I want to read the message. I want to read the message. with the $6.66 from Johnny the Goat, for my wife told me to send this. Well, I appreciate you, Johnny. Thoughts on the new planetoid Ammonite? It's neat. I mean, we have a lot of those. They're, like, look, the solar system has a lot of small stuff in it. Ammonite's just the newest small thing that we saw that's bigger, slightly bigger than other small things. Is it possible that dark energy could be another or multiple new fundamental forces? It's possible, yeah. People talk about that. Oh, if the three-body problem is unsolvable, then how has the solar system been stable for billions of years? The three-body problem isn't unsolvable. We have solutions to the three-body problem. The thing about it, and also you're making a categorical error. Just because we can't solve some math doesn't mean that like there's not like a configuration that is stable. Doesn't mean that the universe can't be that way. Yeah, so they're kind of unrelated. Do you think the universe is infinite or finite? I'm fairly agnostic, but I lean towards infinite. What's your view on the Fermi paradox? Universe big. Light speed slow. Does the wave function collapse imply superluminal information transfer, or is it a measurement artifact? We don't know if the wave function collapses at all. But even if we did, even if wave function collapse was a thing, there's no information transfer. Black holes distort space and time. Is black hole singularity where space and time switch, time ends? No, so the space and time switch at the event horizon, not at the singularity. We don't even know if the singularity exists, but yeah, so that switch happens at the event horizon. With the $10 from Craftinators, thank you. Loaded question, but what's your opinion on space-time being an emergent property from particle interactions that when sufficient particles are in an area, space-time emerges? I'm on the fence about it, honestly. I think that they're like the thing is, and this is, you know, any good scientist should have this position, that like generally speaking, as far as quantum gravity is concerned, which, you know, emergent space-time and black holes and all these things are about, we just don't have data on this. And we don't even have like good solid theories on this that are like definitively like the best theory. So like I might have like a pet theory, like I have a pet theory that like the universe is like a cyclic and blah 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 blah. But honestly, like I don't trust that theory really more than anything else because we don't have data. We don't have the data that says anything about this. So hard to answer. Unfortunately, I'm kind of on the fence about it. Do you believe in gravistars? Again, on the fence. It's a neat hypothesis, but we don't have any data that supports it. If I want to be a mathematical physicist just like you, which major should I learn first, math or physics? Get both. Do them at the same time. Do you think faster than light particles such as tachyons exist? No, I don't. Oh. How do you think physics will look in 1 million years? I have no idea. I don't even know what it'll look like in 50 years. Please explain quantum information science in layman terms. It's not my field. Like I could make an attempt. But well, it's a whole field. I don't even know what you're asking. Like, yeah, no, I'm not gonna make an attempt and then ramble for a while. Did I not send one out? Wait, did I not? No, I sent out a live announcement, definitely. Did T-Rexes have feathers? Maybe. At least as a juvenile, they may have. Yeah. The three-body problem in the orbits of our solar system planets are not related? Okay, no, so you're misunderstanding. That we don't have a closed-form solution to the three-body problem is unrelated to the stability of the solar system. The solar system doesn't care about how good we are at math, right? Now, what is true is that our solar system, the way you would describe it is as like a, you know, a trillion body problem or something like this. There's a, you know, there's a whole bunch of stuff. And we might not be able to solve that problem. We might not be able to fully describe it mathematically with perfect exactitude. But like, the solar system doesn't care how good we are at math. It's just going to do what it's going to do. Can you grow out your beard, please? Nope. No, I cannot. I will not. Do you believe Hawking radiation is real? Yeah, I'm pretty convinced that it's real. So there is a maximum size that black holes can reach. Practically speaking, yeah, because they grow, they only grow so fast, and there's only been so much time for them to grow. But like hypothetically, they could in principle be as big as anything, I guess. Do you hold on? Um, Dasha, I remember. Don't worry. How long are you planning on streaming for? Maybe another 15, 20 minutes. Does gravity only attract, or can it push away too? It can push away. For example, if you have a negative pressure density and a positive energy density, that can be a pushing force. That's kind of what dark energy is supposed to be. Also, rotating black holes can repel other rotating things for very weird reasons. So yeah, it can be repulsive, it's just not common. Do you do lives to procrastinate doing your own research work? No. Since it's summer, this is my primary source of income. So I kind of spend the first few hours of my day doing creating videos and doing live streams. And then I spend the last 5 or 6 hours of my day, like the afternoon, working on research. So I'm self-funding my research over the summer. All right, Mikey, stop spamming, please. If our universe is a black hole, then black holes can be as massive as our universe. Well, yeah, but that's a big if, right? Do you lean toward or away from determinism? I lean toward determinism. What's your research? I do a lot of so I do primarily differential geometry and relativity stuff, and I dabble in some quantum gravity stuff. Explain the strong and weak nuclear force. Like, where do they come from? Well, that's like asking where does electromagnetism come from? It's just a feature of a universe. But the strong nuclear force is a lot like electromagnetism, except because it has more than one charge. So electromagnetism has only one charge, and it can either be positive or negative. The strong nuclear force has 3 charges. It has red, green, and blue, anti-red, anti-green, anti-blue. They can combine to form neutral in more than one way. You can either combine red and anti-red, for example, to make neutral, or you can combine red, green, blue to make neutral. And as a consequence, what this means is that you can have essentially, as a consequence, this means that the force carrying fields, so the electromagnetic field, has to be neutral. Because of the mathematical description, it has to be basically a combination of positive and negative. And that means that it's 0 for the electromagnetic field. For the strong force, the strong nuclear force, it has to have a positive, the field has to have a positive and a negative piece, but it could be a red and an anti-blue. So that means that it can be charged and it can interact with itself, which makes the force really, really strong. And it just pulls a lot tighter. And this is what keeps protons together. This is what keeps protons attached to neutrons. The weak nuclear force, very, very different from either electromagnetism or from the strong nuclear force. This is a kind of a transmutation force. It can transmute electrons into neutrinos. It can transmute quarks into other quarks. So, yeah, I mean, there's a lot to say. $2 from Nectu. Are you remembering to hydrate for Grimlock? I did. I always remember whenever Grimlock sends me a Cash App, I always remember to hydrate. Whenever anybody reminds me to hydrate, I remember to hydrate. Have we gone anywhere with string theory yet? Yeah, string theory has made a ton of progress since the 80s. Oh, actually, I wish you great breakthroughs in your research and peer reviews. Actually, one of the papers that's been in peer review hell for like the last 2 years, we just got an email back that the paper was finally accepted. So that's good. That's good and neat. Will global warming have any effect on the rest of our solar system? No, not really. I mean, it happened to Venus and nothing happened to us. Can you explain your entropy paper since you can't provide it? Yeah. So the idea is, it's actually really straightforward. So the idea is it possible to have a quantum field that consistently exists and is well defined and is the source for an expansion and contraction of a universe in a way that it's exactly periodic? and which makes the time coordinate exactly periodic. So you would have the universe expand with the quantum field, and then the universe contracts with the quantum field. And if you adjust your quantum field just right, if you set up the initial conditions just right, you can make this happen. There's something called the trace anomaly, which can contribute to, in some way it contributes to the contraction effect. And then if you attach a cosmological constant and you make the topology of your universe just right, so this universe has to be finite in size, it can't be infinite. Then you can have solutions to the Einstein field equations that lead to an exactly periodic scale factor. It's expansion and contraction. $2 from Craftinators. Thank you. What are you interested in right now? Have money. What am I interested in? I'm working on a lot of things. I don't have like a pet project right now. I'm trying to finish up a lot of projects that have been ongoing for a long time. So what I'm interested in is finishing up those projects so that I can start some new ones. That's what I'm interested in. Is there anything new happening with Higgs boson particle research? Probably. Almost surely they're doing better and better measurements, etc. Research 3i Atlas. I read the paper already. Avi Loeb was selling a whole load of hot steam of hot air to the media. Did you hear about the discovery that our universe might be in a black hole? It's not a thing. It's not a thing. You've been misled. There's not even a hypothesis for it. Why are south and north poles of magnets different strengths? They shouldn't be. Not if it's symmetrical. Scrap those old projects? No. Why would I scrap those old projects? They're like mostly done. They're mostly done and then we can publish them. Like, why would I scrap them? Where do you end up finding research papers on a wide category of subjects? Do you have a place where you can just scroll through new papers? Yeah, so there's a website called archive.org, ARXIV. It's pronounced archive because it's a meme. It's a joke. On the archive, it's a preprint server. People just upload their preprints there all the time. That's where you'll find most physics papers and most mathematics papers will appear there before they appear in print. So infinite entropy requires edges in unit. So it's not an edge, it's finite, but it closes back in on itself. So like the surface of the Earth is finite, but there's no edge to the surface of the Earth. Is energy even conserved in an expanding universe? Not really. There's no local energy density, no. Is ADF CFT theory kind of dead? No, it's still hugely active. New telescope proved Big Bang for being false? Well, it didn't. Stinky Ethan with the $2. Why is it not cheating to use spin zero fields? There are spin zero fields. The Higgs boson is one. The Higgs boson is a spin zero field. You're allowed to. And I could have used like massive fermions if I wanted to. It just would have made the math more annoying. Do you know anything about Jabilsky's star? I do. I've made a video about it. Jabilsky's star. That's how you pronounce it, by the way. But yeah, I made a video about it a while ago. It was really interesting to research and learn about. I think that it's really, really hard to come to any absolute conclusions about its content because it's such a strange star. Not the Bible Jason with the $5. Thank you. If physics wasn't the path, what real science would you have chosen instead? Landfish. Kidding. Real question. You awesome. I don't know. I don't really find chemistry or biology interesting. So I don't know. I really don't know. Or like sociology, like maybe linguistics. I find linguistics really interesting. I dated a woman with the last name Zibilowski. Yeah, Polish names are hard. Polish names are really hard. You know, when I was recording that video for the Shibilsky star, which is that I'm pronouncing it quickly, so it's not quite right. I spent like 10 minutes trying to get the pronunciation right before I was comfortable saying it. Zibilsky. Yeah, there's like a little like B or P sound at the beginning. Zibilsky, right? Do you think a PhD in aerospace is worth a potential increase in pay over masters? It'll take a long time. So I think that the only people who do PhDs are really the people who are like who want to do PhDs. I don't know if a PhD is generally advisable if you're just going for the pay increase because you lose like 3 to 5 years of your time. Are tau neutrinos more massive than electron neutrinos? We don't know. We actually don't know. Which of the word origin well-established theories you more in favor? I don't know what that's saying. Will you tell me if my paper is trash? Nope, I have a policy of not reviewing theories. Where do I donate? Well, YouTube is one place to do it. There's also a Cash App in the link tree in my bio if you'd like to support me. By edge, I mean end. No, so there's not an end. There's not an end to the surface of the Earth either. Mr. White, thank you for the galaxy. I appreciate that. Is gravity just emergent from quantum entanglement? Maybe. Rejected for not using fermions. Honestly, if that's the rejection, I'm going to get so mad and I'll just do it. I'll just do it. I'll do it again. All it does is it just changes the inequalities. What's the smallest current thing we can actively detect? Not theoretical. We can detect neutrinos, we can detect electrons, we can detect photons. These all none of them have any measurable like finite size. So why do you have a policy of not refuting theories? It takes too much time. Is the art in Edge of Eternity's Physicist approved? I like a lot of the art, honestly. Why do you lean determinism when we've had the results from the Bell test for decades? The Bell test doesn't imply non-determinism. It implies there are a few potential implications. One of which is the many worlds interpretation. The many worlds interpretation is deterministic. Should we accept hidden variable theories like Bohmian mechanics over standard quantum mechanics? I don't know. I mean, you can. I don't know why you would, but you can if you want, I guess. Could you please confirm if JWST shut down? I don't think it did. I haven't heard about that. Honest opinion on UAP sightings? I don't think they're aliens. Do the ether planes exist? No. Where does the universe energy come from? I think it's probably always been here. Or I don't think that there's ever been a state where it wasn't here. Let me put it that way. If someone wrote and published a paper interesting to you, you might reference it and write on the topic. That's a loophole for those who really want this guy to review their work. Yeah, so look, if you want me to look at your work, get it published somewhere or post it on the archive. But I'm not going to sponsor you to get it on the archive. What if you get selected for peer review? Then I'll do it. I will absolutely do it in a professional capacity, but I'm not going to volunteer to do it more. Peer review is already done on a volunteer basis, and it eats up a lot of time. What did you do for your PhD research? I did my research was on conformal geometry with applications to the ADS CFT correspondence. Were you on Jeopardy recently? No, I was not. What's the distinction between always been here and never been a state where it wasn't? So the universe could have had like a temporal beginning. There could have been a first moment of time. And then in some sense prior to that, whatever that means, there could have just been a non-temporal state of existence for the universe. In which case the energy still would have been there, depending on how you define energy. And so there would have never been a state where energy wasn't present. But there might have been a state where time wasn't present. So when you say always, it sounds like that time goes on forever backwards, but that might not be the case. Which physicist has the most mana? I don't know. If time dilation is symmetric, who actually ages slower? No one ages slower. Like there's no definitive answer to that until they meet up again. Do you have any interest in the search for dark matter? I mean, yes, but it's not my area. So JWST is getting a budget cut? Really? Oh no, that's not good. Oh, this is old news. Still pretty significant though. That's really significant. Like 20 to 35% or something. Is the conclusion of Michelson-Morley experiment invalid because of Einstein's second postulate? Well, I don't know what you mean by invalid. The experiment obviously is valid. It's an experiment. The data is the data. The conclusion that they came to, that there's no ether wind, is fine. What happens when the twin meets again? It depends on who changed their speed so that they can meet up again. If one of them is here, and then the other one goes past them, turns around, and then comes back, the one that did the turning around is the one that's going to speed. Is the one that's going to is one that's going to age less. And not until they meet again, parallels with quantum mechanics. No, not really. This is just a relativity thing. Knowing what you know now, would you do your PhD again? In this environment, it would be really hard to justify. But if I could get into a PhD program in this environment, I still would. I might do it on a different topic, but I still would. Have you ever had to cover the whole course 2 days before exam? You mean cram? I mean, I guess. How does the twin paradox have a real age difference? Because in the twin paradox, somebody goes out far and then comes back. And so the real age difference happens because they meet up again. Are you a PhD or a graduate student? I have a PhD. I'm not a grad student. I haven't been a grad student for 3 years. Craft the Natives with the $5. Thank you again. If you could choose any physics issue topic to be resolved, figured out today, what would you choose? On the fence about it is not acceptable. To be resolved or figured out, I'd like quantum gravity to be figured out. You kind of need a PhD to work in the semiconductor fab industry. Okay, that's probably fair. I can understand that. Semiconductor fabrication is really complicated and really specialized, so I can understand why you would need a PhD for that. If we can't cool anything down to absolute zero, isn't possible, then how do we achieve negative temperatures below absolute zero? Right, so negative temperatures are kind of like an artifact of how we define temperature. So the way that we define temperature is it is the inverse of the... Let me make sure I get the units right. So entropy is joules per Kelvin. Or entropy is joules per Kelvin. You differentiate with respect to energy, and you get per Kelvin. So yeah, so temperature is the inverse of the derivative of entropy with respect to temperature. Sorry, with respect to energy. So what can happen is that if you have a quantum system that has a finite number of degrees of freedom, meaning that there's like a maximum energy that it can attain, and there's a discrete number of possible energy, there's a discrete number of possible energy states, then it can happen that you can put so much energy into the system that increasing the energy just puts more particles in the highest energy state. And so what that means is that you end up with fewer total microstates because they're kind of sorted again. Think about being very, very cold. All of the particles are in the lowest energy state. If you put the maximum amount of energy in, they'll all be in the hottest energy state, or the highest energy state. And so the number of microstates goes down after a certain point as you keep adding energy. And what that means is that the entropy also goes down as you keep adding energy to these very peculiar quantum systems. And so what that means is that if the entropy goes down when you add energy, that means that the derivative of entropy with respect to energy is negative. And because temperature is the inverse, it's 1 divided by the temperature is that derivative, then you can get a negative temperature. So absolute negative Kelvin temperatures are hotter than infinite Kelvin. Infinite Kelvin would be exactly uniformly distributed. It's very weird, but is information the 5th fundamental quantity? What are the other 4 fundamental quantities? Do you know if Newton-Cartan gravity is used in quantum gravity research? Yes, it is, because it resolves some of the singularity issues, so people use it a lot, yeah. If objects experience time at different rates depending on speed, how is the age of the universe calculated? Yeah, it's a good question. So we pick a particular reference frame and use that as the basis for a calculation of the age of the universe. That reference frame is called the co-moving reference frame. Essentially, it's the reference frame of an object that's far away from any gravitational source and is not moving with respect to the cosmic microwave background radiation, meaning that if you look in any direction, the sky looks basically the same. That's the reference frame we pick. And then in that reference frame, the universe is 13.8 billion years old. It also happens to be the case that that's the reference frame where the universe is young, or where the universe is oldest. If you were anywhere else, moving at any other speed, the universe would appear older. The universe would appear younger. The observable universe, anyway. What do you think of the concept that our universe is inside a black hole? I think that it's a neat shower thought that has not been verified at all. Where was my education? I'm not telling you. Any thoughts on 3i Atlas? I already made a video about it, but it's almost certainly not an alien. Even Avi Loeb says this. They spotted water in space. We've seen water in space for a long time. What does the weak nuclear force do? So the weak nuclear force does two things, because it has a charged current and a neutral current. The neutral current is basically like electromagnetism, just a lot weaker and a lot, yeah. So in electromagnetism, you can have things with like charges attract and repel, or like charges repel, similar charges attract. The neutral current, for the weak nuclear force does similar things. There's something called weak hypercharge, and the neutral current basically couples with that. And it can do attractions and repulsions and things like this. Now, the charged current, the weak charged current, that is a little bit weirder because it basically transmutes particles. So this is actually how we detect things like neutrinos. A neutrino will come in, interact via a weak charged current, and it will become an electron. The neutrino literally becomes an electron. That's very weird, but it has the same mathematical structure as the other forces, so we call it a force. Stinky Ethian with the $2, thank you. If the field is also zero dimension, is that cheating? No, it's not cheating. You're allowed to have zero dimension fields. Not cheating. They could exist. At least I think they can exist. Hope they can exist. Other people have talked about them. What happened before the Big Bang? I don't know. Have you seen the guy who made plastic waste into gasoline went missing? His mom reported that he's fine. God, you guys are so conspiracy brained. I hate that. I hate this so much. I hate the world that we live in. Is energy even conserved in an expanding universe? Not in a local way, but globally you can define it depending on what shape the universe is and so on. Have I seen the movie Arrival? I have not. What are your thoughts on free will and determinism? I'm a determinist in a sort of quantum-y way. Could causality ever be violated without breaking known physics? Probably not. Do gas planets even have a surface? They might have a solid core. They definitely have superfluids in them at high pressures, which are almost like oceans. But it's kind of like a slow gradient, right? It's not really like a abrupt surface. From Craftinator with the $5, thank you again. My professor loved calling the weak force the weird force. I think it's pretty fitting. It is, and I will hydrate. Thank you, as always. What is your thought on quantum computers? Do you think that they will be useful in a few years? Look, I don't think that they'll really ever be like useful for everyday people. Quantum computers are not magic. They're just good at solving particular problems. Like we can prove that certain problems are more efficiently solved by quantum computers than by classical computers, but that's not everything. Khamzat or DDP? Is this a RuneScape reference? Oh, no, it's not. No, this is a UFC reference. That's funny. Overly polite rebel with the $2. Your thoughts on our universe being a black hole? I don't think that there's any evidence to support it, but that's because there's no hypothesis that supports it. Look, so a DDP was another name for a DD or for a DD plus, right? Is a poisoned dragon dagger. Okay. I don't know anything about UFC, by the way. Has life originated on Earth? I suspect so, but that's not my field. What, if anything, is transmitted in scalar waves? The only scalar waves that have been proven to exist is the Higgs boson. Does the concept of quantum entanglement challenge our classical understanding of locality? Perhaps, yeah. Graham Spellman with the $5. Do you have any ideas analogous to BCS theory, but for the Higgs mechanism instead of the Anderson Higgs? Do you scoff at me putting my mysticism in there? Well, I don't know why you would put mysticism in, like, quantum field theory. Just because it's unexplained, I wouldn't put mysticism in there. But no, I don't know a lot about BCS theory in general. I'm not a condensed matter person. I'm not even a high energy physics person. I'm like mildly familiar with it, but yeah, I don't know why you would put mysticism in there. if it's just like to fill a gap, right? Um, did you choose that haircut? I mean, I just have long hair, right? And so I just like to keep it out of my face. What's your opinion on CERN? It's a neat place where a bunch of cool nerds do cool physics. What are your thoughts on Mond? I'm not convinced that Mond is correct, but look, I'm happy to be wrong about that. Have you ever played the first two Baldur's Gates games? No, I never did. I only played the third one because people were raving about it. Is gravity real? Yeah, of course it's real. Can you answer any space questions? Sure. How do X-rays work? How are they produced? So X-rays are generally produced by electrons either accelerating very fast or slowing down very fast, like slamming into things. Whenever you accelerate a charged particle, like an electron, it can emit, or rather it does emit radiation. And so if you have really, really fast electrons and you slam them into something, it'll produce X-rays because they'll stop all of a sudden. How does static work against gravity? Well, look, static electricity produces an electric force, and that electric force can be in the opposite direction as the gravitational force. And if the static force is stronger than the gravitational force, then the static force will win. Thoughts on FDL processes that don't break causality? They probably all do. Kind of by definition, actually. They kind of have to. Do you think the state should give more resources to physics studies? Yes, I do. But I'm biased. If there are infinite stars, is the blackness of space caused by the emptiness or the light not reaching? This is Olber's paradox. It's caused by kind of three things all working together. It's caused by, first, the universe is finite in age. At least the first stars have not always existed. The first stars only started to exist 13.8 billion years ago. Second, the universe is expanding. There's a third thing that I'm missing. What's the third thing? Okay, let's just say two things. So the fact that the universe is finite in age means that you're never going to see an infinite number of stars, even if the universe is infinitely large. Second, the universe is expanding. So that means that even if you waited forever, you would still never see infinitely many stars because some stars are just moving away from us too fast for the light to ever get to us. Your Discord link in the link tree has expired. It should be an infinite link, so try copying it. It might just copy it into a browser and it should work. Oh yeah, reminder, go join the Discord if you haven't already. It's a great place to ask me questions, to talk to other like-minded people. Yeah, so definitely do that. So if you're a determinist, do you think there's something like free will? I mean, if by free will you mean like, is it possible for people to be responsible for their actions? Sure. If by free will you mean like the ability to have done otherwise, I suspect not. What do you think of Sabina Hossenfelder's skepticism when it comes to building new colliders and the state of the foundations of physics as a whole? I think that she is overly cynical. What is our best guess for where the space is coming from universal expansion? Doesn't new space get created everywhere? It's not really new space, it's just stretched space. I don't know how you would differentiate between old and new space. How does entropy even work? Where does the lost entropy go? Entropy is not conserved, so it's not like a thing that's either gained. It's not like a something where like the entropy has to go somewhere. It's just a property of a system. It'd be like saying where did the speed go when you press on the brakes? Like the speed just changed. It can just do that. Where's the stretching? The stretch stretches everywhere. Everywhere where there's not strong gravity. Can space move faster than light? Space, I don't know what it would mean for space to move. Space is how we measure motion, right? Are the physics strange about the comet approaching? And Avi Loeb even said in the paper that the most likely solution is that it's just a interstellar object, like a comet. Are there X-rays hitting us or the thing behind the bone being seen? I don't understand the question. I know Professor Dave made a video about him. Why do people think that time is the fourth dimension when it doesn't exist without gravity? Time can exist without gravity. Time and space are a form of four-dimensional space-time. All right, y'all. It has been an hour and 45 minutes, which is a little bit longer than I usually go. So I'm gonna end the live here. If you want to ask more questions, the place to do it is either to come back next week on Tuesday or to go join my Discord. If you haven't already, there's a link in the description of the TikTok video or of the YouTube video that you're currently watching. Or you can go to the link tree in my bio on TikTok and you'll find a link to the Discord there. The only thing is you can't click the link from TikTok. You have to copy it into a browser and then it'll work. I don't know why that happens, but that is how it is. Yeah, and if you want to support me, you guys know how. There's Cash App, Buy Me a Coffee in my bio. I'll see you guys next time.